characteristics of the planets. Our solar system, first off, we need to know the order of the planets and their characteristics. We have, starting up here at the top, I always use the mnemonic, my very educated mother just served us nachos. So we have my very educated mother just served us nachos. Now we have this other little planet up here. I'm not including with our little mnemonic here. It used to be my very educated mother just served us 9 pizzas, and we had a little P out there. Of course, that little planet is Pluto, but now it's just nachos instead of 9 pizzas. So of course, the M is for Mercury, the V is for Venus, E is for Earth, M is for Mars, J is for Jupiter, S is for Saturn, U is for Uranus, and N is for Neptune, and little p out here is for Pluto. Pluto, of course, is no longer considered a planet. It's now considered a dwarf planet. It had some unique characteristics to it that it didn't play by the rules of the other planets a little bit, mainly being that it wasn't, we started finding these other things out in the Kuiper Belt that were just as big as Pluto, and so instead of adding a bunch of new planets, we just kind of demoted Pluto down a little bit to a dwarf planet. So the characteristics of these, first off, you have the inner and outer planets. The inner planets are the Mercury, Venus, Earth, and Mars. We'll circle these guys right here. And then the outer planets are Jupiter, Saturn, Uranus, and Neptune. And we're going to leave Pluto out of our discussion here with this one. They each have similar characteristics to each other. Mercury, Venus, Earth, and Mars, these are the inner planets. They are all like Earth. They are rocky. They're fairly small compared to some of the other planets. They have, they all have, large iron, well, not large iron cores, but they have iron cores, some larger than others. The gas giants, the outer planets, they all have similar characteristics to each other that are pretty much the opposite of Earth. They're massive in size, and they are not rocky. They are mainly, well, they're called gas giants. They're made out of hydrogen and helium. Number 1 and number 2 on the periodic table. They're the same material that our sun is made out of. In fact, all of these planets out here are leftover material of the formation of our sun. We're kind of leftover debris floating around. Just some quick things about the planets. Mercury is our smallest planet. It is not it's the closest planet to the sun, but it's not our hottest planet. Mainly because Mercury doesn't have an atmosphere. Atmospheric gases trap heat. That's why on Mercury it can be, like say 250 degrees Fahrenheit on the daytime side, but when you go to the nighttime side facing away from the sun, it's like negative 250 degrees. So it's like the most extreme temperatures, but it's not the hottest temperature. It looks a lot like our moon, heavily cratered. Venus would be the hottest planet. It's the second in line, but Venus has a large carbon dioxide atmosphere, that's a greenhouse gas. We'll talk about that when we get to meteorology, but it's farther away than Mercury, but those greenhouses, those gases trap that energy, and Venus would be the hottest planet. Venus is also known as Earth's twin because it's similar to us in size. It has a counterclockwise rotation. A clockwise rotation. Everything else in the solar system is counterclockwise. Venus has a clockwise rotation to it, so it's a little bit of an odd planet. Earth, of course, is where we live at. It's the only planet that has water in all 3 states that we know of. It's the only planet we know of that has life on it. The reason why we have life here, not in other planets, is because we live in what's called the Goldilocks zone, where we're not too close to the sun, we're not too far away from the sun, we're just right. And of course, Mars. Mars is the red planet. It's mostly rusted iron. It's what they call hematite. It does have the largest volcano in the solar system, Olympus Mons, or Mount Olympus, the name of the Titan's home. Jupiter is the biggest planet. Jupiter has the Great Red Spot that we see right here. It's a giant storm, like a hurricane, but it's been raging for well over 300 years, and who knows how much longer it will go. It's also hydrogen and helium. Of course, all the gas giants are hydrogen and helium. Saturn's most famous for its giant rings. Uranus is it's also hydrogen and helium. Same with Neptune. The bluish color, though, comes from, they're just trace gases, the same thing that the browns and tans come from. So the bluish would be a methane that's on Uranus. And Neptune is also methane. Neptune also has a storm as well, just like Jupiter does, but it's called the Great Dark Spot. It's also a giant hurricane. Neptune also has some of the strongest winds in our solar system. And of course, little Pluto is now considered a dwarf planet. We sent the New Horizons spacecraft by there a few years back and took really great pictures of Pluto. But it's more of a Kuiper Belt object, they call them. We've been finding other things that are about the same size as Pluto. So we kind of, instead of lumping in here with these big guys, the outer planets, as the outer planets and the gas giants, we demoted Pluto, or not really demoted. It's kind of like the king of the Kuiper Belt objects now. And the other thing to remember, speaking of Kuiper Belt objects, is that's where there's these objects out there like Pluto that are icy and rocky that are known as comets. And they sometimes fly into the inner solar system. And anything in our solar system, as it orbits around the sun, it actually takes an elliptical orbit. Even the planets, we see down here the planets going around the sun. An elliptical orbit, it's not a real circle, it's slightly stretched out like a football. And as it goes around, this would be like Neptune's orbit right here that I'm circling, this green one. As it goes around, and it's slightly stretched out, and this is anything. And comets are unique in that as they come on, they have an extremely stretched out orbit. This is Halley's Comet here going around the sun and going back out. So they have an extremely stretched out orbit. It's an elliptical orbit. The tail grows as it gets closer to the sun because the tail is being heated by the sun. That ice starts to vaporize, and it throws a tail that always points away from the sun. What happens is, as the comet comes in, let me change my color here. As the comet comes in, make it red, there's this solar wind that's coming off of the sun, and it's almost like a fan, you can think of it. And as it melts that comet, the tail will always point away from the sun. Whether it's coming towards the sun or going away from the sun, it doesn't matter. The tail will always point away. So you can't tell which way a comet's going based upon the tail. You can only tell which way the sun is from the position that the tail is blowing.